So let us look at the next example. Y is equal to x squared minus 9 divided by x minus 3. A good first step always is to factor out the numerator and the denominator whenever possible to see if factors cancel each other out. And what we see here is we have a common factor that cancels each other out, and that factor is x minus 3. Sorry, it is x minus 3, and I just made a mistake. No worries, let me fix that up. So a factor of x minus 3 is canceled out. However, we still have to maintain that our restriction that x cannot be equal to 3. So this first function represents the function that we're trying to graph. However, we can think of it in this way. However, we have to keep all of our original restrictions. Now, if I look to this function here, y is equal to x plus 3, but x cannot be equal to 3. Fair enough. I know how to do this. It is a line, isn't it? Y is equal to x plus 3, indeed, with a slope of 1. So I make my line. There we are. And you would think I'm done, except for now I need to revisit, but x can't be equal to 3. So I have to take a look and grab my eraser, my pixel eraser. Where is x3? Right there. So what do I have to do? I have to make sure that I put a hole in my graph wherever x is 3. And this is what this function looks like. Really good idea to simplify your graphs first. All right, let's move on to the next one. So now let's look at this next one. Let's mark this up. So y is equal to x divided by x squared minus 4. So I'm just, guess what I'm going to do? That's right, I'm going to factor the bottom. Always really good. And when we factor the bottom, we're able to see our asymptotes. I'm going to take a look for factors that cancel out. None of them cancel out. Great. I'm going to take a look. Okay, so my vertical asymptote here, I'm going to say my vertical asymptote, I have 2. One where x is equal to negative 2, and one where x is equal to 2. My horizontal asymptote, I take a look at my function. What I recognize is that the degree of the numerator is less than the degree of the denominator. So my horizontal asymptote will be y is equal to 0. Also, I'm going to calculate my x-intercept, just for fun. I haven't done that for a while. So when I calculate my x-intercept, I have to consider where y is equal to 0. If I substitute y is equal to 0 into my function, I end up with this equation. Now, I'm just going to point out to you this, sorry, I thought that was a highlighter. This expression is only equal to 0 is if the numerator is equal to 0. So therefore, my x-intercept occurs when x is equal to 0. So that's my x-intercept. Now, obviously, my y-intercept, if you plug in 0 into it, you'll get 0 over negative 4, which is 0. It really doesn't matter. There we have 1 point for sure. Yay, we have 1 point, which is my x-intercept, my y-intercept. But now I'm just going to graph my asymptotic behavior. So if you want to be the cool kid at the party, you can use this asymptotic behavior vocabulary to impress. But I'm just going to draw my asymptotes. There we are. There's one asymptote. It has to be dotted. Otherwise, you're losing marks. I'm going to draw my other vertical asymptote at x is equal to 0. It has to be dotted. Otherwise, you're going to lose marks. Also, Your horizontal asymptote has to be dotted. Otherwise, you're losing marks. Okay, good. I'm glad we all understand that. So I'm just going, really, what do I notice? I notice that I have 3 sections of my function. I have what's going on over, I'm just going to erase this because I put that information. What's going on over on this side, what's going on in the middle, and what's going on over here. So how do I decide what's going on the left-hand side? So really, I'm just going to figure out the f of -8, the f of -3, and the f of -2 that is negative. And in the middle, I'm going to figure out the f of -2 positive, the f of 0, which we already have, and the f of positive 2, but on the negative side. Pretty complicated, right? And then on this right-hand side, I'm going to get the f of 2 on the positive side, the f of 3, and the f of, I don't know, something maybe that looks like 8. All right, let's get in here. The f of -8. So plugging in x into my function here, when x is -8, I get -8 over 64 minus 4 is 60. The f of -3, I get -3 over -3 squared is 9 minus 4 is 5. Now the f of -2, that is on the negative side, I'm going to treat this like the f of -2.01. Now, it might be helpful if you take a look at your factored form. If the x value is -2.01, your numerator will be negative. And then if you look at your individual factors, we have -2.01 minus 2, and then -2.01 plus 2. Now, what we're able to see is that the numerator is negative. This factor here will be negative. This factor in brackets that I've tried to highlight here is also negative. So what we have is, overall, the top is negative, but the bottom is a negative times a negative, which ends up being a positive. So a negative divided by a positive, this will have an overall negative value. So all I'm going to put now here, after I did all that work, is I'm just going to put negative. And I know that as I approach a asymptote, a vertical asymptote, it's going to go down very far negative. So when x is equal to -8, my y value is negative, well, that number is really close to 0. When x is equal to -3, my y value is -3/5, which is about -1/2. When my y value is -2, but on the negative side, I know that my graph is going to go way down. So now, if I was to draw this left-hand side, I would draw it like this. Now I'm going to go what's in the middle. And in the middle, the top factor, x. Now, when I say -2 on the positive side, I'm really thinking -1.99. The top factor is going to be negative. And then let me look to this factor, -1.99 minus 2. Well, that factor is going to be negative. If I take a look at this factor, -1.99 plus 2, well, that factor is going to be a positive. But overall, is a negative divided by a negative times a positive, what's the outcome? Well, the denominator in negative times a positive is a negative. Overall, we will have a negative divided by a negative, which ends up, weirdly, being a positive. The f of 0 is 0. The f of negative 2, or 2 on the negative side, I'm really thinking 1.99. Again, I'm going to plug in my value for my top factor, positive. And this factor right here, 1.99 minus 2, is going to be negative. X plus 2 when 1.99, when x is 1.99, that factor is going to be positive. Overall, this expression will be negative. So I'm just going to draw this. This point is, I'm getting very, very, very close to my asymptote at negative 2, but on the positive side. The resulting will be positive. I'm going to approach my asymptote, this asymptote right here. This one right here I'm talking about. I'm trying to draw your attention to the right one. So when x is 1.99, it's going to be on the left-hand side of this asymptote. My y value is negative. So I know that it goes all the way down to negative infinity. So what does this graph look like in the middle? Well, it's going to look something like this. And if you don't believe me, if you want greater precision, you need to calculate the f of negative 1 and the f of 1. Similarly, we can evaluate this, and what we're going to see is that this graph will look something like this.